The new driver that we had used a stainless steel 2-inch chem hose, right? It's 2-inch chem hose with stainless steel fittings for bleach. He was not trained not to do that. He didn't know, and it just came off of a truck, and I didn't know that it had bleach in it, but he took a 20-foot delivery hose, coiled it twice, and cam locked it on itself. So it was a closed system. It was empty, it was blown out, but there was enough residual hypo in there that it reacted with the stainless steel fittings and generated a little bit of gas. And when I opened the cam lock on that hose, it blew apart like a shotgun. And one end went that way and one end went that way. And it was not fun. Not something I want to repeat. That being said, if you have on the suction side of a pump, for example, a foot valve that doesn't let anything go that way, and some sort of like a peristaltic pump, or I missed that word last time too, progressive cavity pump that doesn't let anything go that way, you don't vent that line, same thing, shoot you in the head. It only takes a couple of minutes, a couple of hours. You can generate a small amount of pressure, and it doesn't take a lot of pressure to have, you know, a little bit of spurt go into under your goggles or around your face. That is what you really have to think about every time you go to a chem line, whether it's a delivery truck with a 2-inch, 3-inch cam lock, or half-inch tubing. When I open that system, what is the potential for there to be pressure in that system? When I do that, I vent everything before, right? There's a vent on the back of the trailer. I know there's no pressure in there. There's a vent on the top of the pump. I know there's no pressure on that side. There still may be pressure on that side. What can I do to relieve the pressure before I open anything that's going to shoot me in the face? The other side of that, vacuum, of course, is there are some chemicals that are heavier than others. Certainly sodium hypochlorite is heavier than water. Sodium hypochlorite is 10 pounds per gallon, and water is 8.34. So, that being said, if you have a tote, like that one right out there on the cement, if you are drawing off the bottom of that tote, 10 pounds per gallon, 300 gallons, by the time you get to the bottom of that tote, the amount of vacuum in the head of that tote can be enough to have the atmospheric pressure just crush it. And typically that's not a dangerous situation, but I can tell you that I have a personal experience where it was a very dangerous situation. We had a tank in Saratoga, and the tank farm is 8 tanks, all each in their own containment, and then a second row, 8 tanks, all each in their own containment, 10,000 gallons, so they're almost 15 feet high. We had a tank, and it consistently didn't have a good level sensor. And it's a carbon steel tank, you couldn't see through it. So we were manually writing down what we thought the tank level was while we were waiting to get the tank level sensor fixed. And of course, at some point, we overfilled it. And the maintenance crew, in their infinite wisdom, decided at some point that they were going to put a vent on this tank so that if it ever overfilled, it would go out the PVC pipe down and into a barrel. And hopefully, whoever was filling the tank would hear the overflow in the barrel and shut everything off before it made a big mess on the floor. At any rate, that whole system was not well made, and they ended up filling that barrel with liquid. And because the tank was over full, we decided, okay, we'll just drain it out by gravity to get the level back down to where it's supposed to be. So I hooked the tank up to the trailer, and we were lowering it by gravity into over-the-road trailer, and at some point, there was enough vacuum inside that tank that it went boom, and came in about 2.5 feet on both sides. It's like a football. Poof. That vent hose, or vent PVC plumbing, it was a 3-inch PVC plumbing pipe, was in the barrel, and the barrel was full. So as I was drawing the tank down, there was liquid going up the standpipe, and there wasn't any air going in the tank to replace it. And at some point, there was just so much vacuum that the atmospheric pressure crushed the tank. The tank didn't rupture, nobody was hurt, nobody was injured, but there have been situations where tanks like that have ruptured and just put everything, 10,000 gallons, 8,000 gallons at that point, into the containment. That is a real danger, and that toad out there, you know, probably wouldn't do that, but if you didn't vent the top and you drew all of the liquid off, there would be a massive amount of vacuum in there, and the potential is that that could collapse. And it doesn't collapse like a trash can, somebody stepping on a trash can. It collapses like a shotgun. It goes boom, all at once. Makes a lot of noise and mess. There's all sorts of videos on YouTube about people doing that with full tankers, like a 5,000 gallon tanker, making a gravity delivery and not opening the valve on the top. And generally what happens to a tanker is that it collapses catastrophically and breaks. And then whatever's left in the tanker just gets spilled out all over the floor. Typically, a delivery like we make doesn't have that issue because we're adding air pad the whole time. These guys out here, the septic haulers, if they were discharging by gravity and they didn't vent those tanks, at some point somebody would crush one.
Most of our tanks have vents and overflows. So there are 2 ways that the air could get in.
Yeah, I agree. There's been other instances, but you never want to be too overconfident in how good your systems are. There was a company, not ours, that had a scrubber on the tank, and their vent went into a scrubber, and they were filling that tank by air pressure, and the scrubber clogged.
Yeah.
Because it wasn't properly maintained. Poor design.
Yeah, vents could get clogged.
Yeah.
We actually have a water trap sometimes on our overfill.
That's the dangerous one. That's what did our tank in.
Yeah, that wasn't my choice, but keeps the safety, you know, there's a safety tipping point there. Because otherwise when you're filling it up, you could be filling the space. It's not going out the vent, it's also going out the overflow.
Yeah, it's an awareness thing, 100%. You got to know what you're dealing with. The stuff that we talked, again, we did this presentation earlier. I get a little bit ahead of myself sometimes. Explosion is not typically an issue with the products that we are delivering here. I would say that the commodity chemical business in wastewater, outside of methanol, which can be used for nutrient addition, in general, you don't really have a huge explosion problem, although you do have a fair amount of methane gas here. And I assume that the methane gas is piped around the place to certain areas. A leak of methane should be considered a hazardous chemical. Methane is under no circumstance should be considered non-hazardous, because it certainly is. It's flammable, it's explodable. what we really gotta talk about, the real danger, especially with sodium hypochlorite, is pulmonary edema. That's what an inhalation hazard or a hazardous inhalation can cause. It's a sequence of biological response from inhaling corrosive vapors or particulate. It's happened to me. The worst case I had was from calcium hypochlorite. We had a 5-gallon bucket in the warehouse. It was on a rack. It got pushed off the rack by a complacent forklift operator, and it fell two rack spaces onto the floor and broke. And calcium hypochlorite is it's a solid. And like an idiot, I didn't figure it was a big deal, so I got out a broom and I swept it up. And as I was sweeping it up, of course, the dust was flying around in the air. And the first thing that happens is you get a runny nose, watery eyes, you start to cough a little bit, and you start to get congested, you get fluid buildup in your lungs, and you start to get a headache. If you're left in that environment, you'll fall down, and you'll need somebody to drag you out. But in our case, of the hazardous chemicals that we work with, especially sodium hypochlorite, if you get to that point, you know what's going on, and you're just going to evacuate yourself. The real danger that we're going to talk about for sodium hypochlorite is that if sodium hypochlorite gets acidified, it outgasses chlorine gas. So that 150-pound cylinder that we talk about, the green cloud of death, that green cloud of death is in your holding tank. It's just held in solution by the excess alkalinity. And the way I try to explain that is that the way sodium hypochlorite is made, and this is a wild simplification, but you take a tank of water, about 2 or 3% sodium hydroxide, caustic sodium hydroxide, and you bubble in, under the right conditions, chlorine gas. And that chlorine gas reacts with the sodium hypochlorite in the water and makes that hypochlorous ion, and just exists there as sodium hypochlorite in solution, so long as the pH is high and the alkalinity is there. And alkalinity is kind of a fruity little word, but it means water's ability to accept acid. So as you add acid, you consume alkalinity. You may not change the pH, but you're consuming the alkalinity. And at some point, adding acid will overcome the amount of alkalinity that's in that tank, and at that point, you're going to have a catalytic discharge of chlorine gas. And by catalytic, I mean any acid in that solution is going to act to degrade the solution so that the gas comes out and it's not stoppable. The acid is neither consumed nor produced in the reaction, so it doesn't stop. As long as there's no excess alkalinity, the chlorine gas is going to come out of that tank until there's no chlorine gas left in the tank. And there's really no way to stop it except adding sodium hydroxide, which I've done it because I know how to do it, and it was a small tank and it was accessible and all the conditions were right. But from your perspective, if that happens, you're not going to be able to respond. Again, it's not going to be a life or death situation for you guys because, number one, it stinks. Once you smell chlorine gas, like real chlorine gas, you know exactly what it smells like. It garners a fight or flight response, and there's nothing you can do about it. Your adrenaline goes right through the roof, especially the second time you smell it. And you just get out of there. You get upwind, and nobody's a hero at that point, right? You realize that's the situation. And the most important thing of this page here is that, and learning our limitations, my limitations especially. The chlorine gas, whether it came out of the 150-pound cylinder or the 2,000-pound cylinder, or coming out of solution from a hypochlorite tank, that chlorine gas is heavier than air, much heavier than air. So 70% heavier, and it displaces everything else. So if you have a containment vessel and there's the green cloud of death going in that containment vessel, even if you have a respirator that protects you from the chlorine gas, going in that containment is a no-go because there's no oxygen in there. It's only chlorine gas. The other thing about that situation is that the chlorine gas is corrosive to everything, including your skin. So if you are sweating even the least amount, there's always a little bit of moisture on the outside of your skin, it's going to react with the chlorine gas and make an acid, and it's going to burn your skin. There's no, outside of a Scott Air Pack, hours and hours and hours of training, and 2 people to go in and 2 people to rescue them, there's no response for that situation. Your chemical spill response team from the fire department is the only people that are going to respond to like that situation. I know I give you a story of doom and gloom. There's a reason we use these chemicals. They work really well. They're relatively inexpensive. And nobody here has seen that situation, right? It's never actually happened here, but it has happened. And you have to be aware of it. You have to know that it's possible. And if somebody tells you to do something, like add something to sodium hypochlorite, make some real mental note about what you're going to add. If it's even the remotest piece of acid, and everything else you have here could be considered acidic. Ferric chloride, polyaluminum chloride, ferric sulfate, ferrous sulfate, all of those things are to some degree acidic, and some more than others. You really don't want to get those together. And the worst way that this can happen, well, there's 2 ways. The most common way that this happens is at a town pool. The local pool has HTH pucks and bleach tank. And somehow an HTH, I can never remember what HTH is, cyanuric acid. It's cyanuric acid of some form. But it's an acid in that puck. And if that puck gets into a carboy or a barrel or a day tank of bleach, not only do you get the green cloud of death from the conflagration of the bleach, but you also get all the chlorine from the HTH puck. And that's really the only way it happens. It's usually a 20-year-old lifeguard who wasn't taught how to do things, and they just make a big mistake. And in that case, there's only one response, and that's to call the fire department and have them come and deal with it. The other way is that somebody hooks a delivery truck up to the wrong nozzle. And hooking a delivery truck up to the wrong nozzle is not an option. Everything has to be labeled. You have to go step by step with your driver. There's some liability here. There's some liability on our part. It just can't happen. Because if you put stern pack or ferric chloride into a half-full tank of bleach, you're not going to have a good day. It happened once that I'm aware of, and the DEC took the parties involved away in handcuffs. Drove them to Albany and had them arraigned. They don't take that stuff as, it's not something that can happen. That being said, you guys got all your stuff labeled, I'm sure. You're well on top of the driver and the operator, making a collaborative effort to put the right stuff in the right spot. Yeah, it's not just an inconvenience, it could be a very, very bad day. Where were we? Disclosure. waste oxygen, fire, okay. The chemicals that we're gonna talk about from Slack Chemical don't participate in a fire. They're fairly benign in a fire situation. There can be some thermal degradation of sodium hypochlorite. If it gets hot enough, it has a tendency to put out a little bit more of that chlorine gas. When we go through the SDS sheet, we can probably get an idea of what temperature that is. And then we're going to talk briefly about these secondary reactions. Like I said, everything's acidic. Consider everything acidic. Also, like ammonia, makes ammonia and sodium hypochlorite. Pretty much everybody knows that. That's not shocking.
Can I say one thing about the fires?
Absolutely.
Is the DEC inspections, if it's a plastic tank, you need to have a fire extinguisher. Just sort of an odd thing.
Yeah.
Even though the chemical itself isn't flammable, they still want to make sure you put the fire out so it doesn't melt the tank.
Yeah.
So sometimes we run into that. I mean, it's something you wouldn't think, but I just figured I'd just mention it.
Yep, sure. And that's a good starting point, and I see this from having been a manager at a big tank farm, I see this all the time. Employees kind of get complacent and things get messy, and there's stuff in the containment that shouldn't be in the containment, like wood or paper towels or pigs. Pigs are flammable, and if you have, there are circumstances where chemicals can spontaneously combust, and if you get into that situation and your containment's not clean, everything that's in that containment is going to start on fire, and then your fire gets bigger. If your containment is completely clean, which it should be by DEC inspection, they should be spotless, then you don't have an issue. And further to that, if you lose a tank, and I talked about this briefly in the last session, and I want to make the point again in this session, there's a huge difference between a spill and a leak, right? You can leak the entire tank into the containment, but if it's in the containment, it's not a spill, right? The way you report it is a management decision. It's did it make it into the environment? Is it, you can contain it, you can have a discussion about how are we going to deal with it. As if it goes out in the environment, that's a whole different story.
It's a release.
Yes, that's reportable. It has to be reported. Anybody who doesn't report it, again, you're going to go to Albany in the back of the car. But if it's in the containment and the containment is clean, your options are a lot better. What's in front of you is much more manageable. Even if you have to get it pumped out and taken off site, it's a whole different story than if the guy shows up and there's stuff floating in it.
They want you to clean it up in 2 hours.
In the containment. Well, if the containment's clean and you have support, you can probably, you're probably not going to do it in 2 hours. That's ridiculous. But you can start the response in 2 hours.
Yes.
How's that?
Yeah.
You work on the paperwork. I'll work on that.
Right.
That kind of thing. But I do see it. I walk into these places all the time. I mean, I service 400 wastewater plants, and I get in there and I'm like, you just clean it up. I mean, I know it's not easy, and it's a terrible, shitty place to work, but keep it clean, and it's just a lot easier for everybody. I would like to say strong oxidizers outside of sodium hypochlorite, but because sodium hypochlorite is kind of a special case, it is a super strong oxidizer. It's a really strong pesticide, disinfectant, but it doesn't, again, it's this complacency thing. It's not dangerous like a strong oxidizer should be. If you get a spill of even the strong 15%, 12.5% on paper, it's fine. The paper might get warm. It's no big deal. But if you have anything above 35% hydrogen peroxide, or sodium permanganate, or a solution of potassium permanganate, if they come in contact with paper, you're gonna have a fire. It's gonna go. And it's non-intuitive. You wouldn't think of that. And I can tell you another story. I have to tell you a story. There was 4 drums on a pallet. One of the drums had to go on another pallet, and there was liquid on the top of one of the drums. And of course, I can do anything. Grab onto that drum with my leather gloves on, and I wrangle it across onto the other pallet. So there's 1 pallet on one and 3 on the other, and I turn around, just turn around and put my hands on the other drum and start to try to square it up, and my fingers were on fire. Because that liquid that was on the rim of that drum was 50% hydrogen peroxide, more than water. And my gloves started on fire. So I know that it's kind of an extreme case, but it just goes to the point of keeping the containment clean. Because there's reasons other than looking good or hygiene to keep the containments clean. Let's have a conversation about corrosiveness. Everybody sees the placard on the truck. It's 8. It's got the glove with the drip on it. It's corrosive. Okay. What does corrosive mean to you? Well, what it means to me is that if it gets on your skin, it's going to corrode your skin. You're going to get a chemical burn. That's true. 100%. Some worse than others, as we talked about it. But there's a lot more to that, too. It could be corrosive to metals. Could be corrosive to the building, the interior of the building. What is it corrosive to? And it goes to the materials of construction, it goes to the engineering concerns, and when we go line by line through the SDS sheet, we'll talk about it. But one of the things of strong oxidizers, specifically sodium hypochlorite, it's corrosive to every metal except hastelloy and titanium. Every other metal, number one, will disintegrate sooner than later. Brass, bronze, copper, stainless steel, aluminum is just going to turn to dust eventually, some faster than others, and it's going to contaminate the product. Specifically, iron oxide. If there's oxides of iron from a washer, a nut, or a bolt in a tank of sodium hypochlorite, that sodium hypochlorite is going to be degraded catalytically. Again, the iron oxide degrades the product, but it's neither consumed nor produced in the reaction, so it always stays around. It's not like the bleach will consume all the iron and then it's done. The iron oxide acts as a catalyst. Virtually every time, probably 90% of the time, knock on wood, a customer calls me and says there's an issue with the strength of our bleach. It's either 6 months old or there's something in the bottom of the tank. First thing I do is get into their day tank and I lift the cover and I stick my head up, and most of the time there's little bubbles coming off the bottom of the tank. Those little bubbles are oxygen, and the reason that there's oxygen bubbles is because the solution is catalytically degrading. And a bleach tank that should last 2 months has gone off in 2 weeks or 5 days. And typically, especially if it's iron contamination, the tank will be brown, the water, the liquid will be browner or blacker, and there'll be some stuff floating on the top. But that could happen with stainless steel, carbon steel, brass, bronze, copper. Aluminum just turns to dust in that environment. So, that being said, if you've got a plumbing problem and you want to make a